spread of the number is like this, let's say. If you add a number in between, the spread has become less, right? So let's say there are students who have scored this, whatever is this. So that is what is exactly happening here. The spread. Oh, wait, this was exactly what is asked, right? I think I'm doing something wrong. Okay, so S1 is actually greater than S1 is actually less than S. This is an example for that. But what about the positive counter example where it is asked that, so in this case, where did it go? Yeah, in this case, this turns out to be greater if all the numbers are positive. That means we need to take a counter example. This actually doesn't prove anything. So we have to take a counter example where S is less than S1. So let's take x1, x2 now as 1 and 1, and this is the mean. Sorry, no, it cannot be because the variance is greater than 0. So that is important. So 1 and 3, and the mean is 2, right? So in this case, the standard deviation here is nothing but 1 square tenths minus 10 by 2, that is 5. Did I do something wrong here? No, it doesn't seem like. Let's see if I have done something wrong. So x1 and x2, the mean will be 2, which is added as a new number because the mean is equal to this. So the standard deviation here is s is nothing but, so we are doing s square. Let's say s square is nothing but 1 square plus 2 plus 2 9 10 by 2 5. So 1 square plus 3 square by 2 5 minus the mean square 4. So it's 1. And now if you want to do s1 square, say s is equal to 1. If you want to do s1 square, then it's nothing but, again, 1 plus 9 10 plus 4 14 by 3 minus the mean square, right? That is 4. So it turns out to be 4 point something, which is less than. Okay, this is interesting. I think I have done some calculation mistake somewhere, and you have to figure it out. And also that makes intuitive sense, right? So because if x1, x2, xn are a set of numbers, whatever its variance, if we add a number inside of it, like whatever the mean will also always be inside, right? If we add the same number, that means the variance, the reduction, the dispersion has reduced to a smaller set, right? So somewhere I have done some calculation mistake, and this seems like true actually, because here, so let's see where I've done the mistake. Okay, I see where I've done the mistake. So the mistake I have done is here, that this n plus 1 should also be here, and this n should also be here. It is just on this. So let's recalculate this. So we take the m here. So let's see. So it's summation of xi square minus nm square. And the n plus 1 is coming from that side. And here it is n times, again, summation of this plus 1 whole square minus n plus 1 m. So this is what I have missed before, times n. Okay. This will be this, y from 1 to n minus n times n plus 1 times m square. And here it will be, again, I will do it in a similar manner. So I will keep it till n xi square plus I will do n times xn plus 1 minus again n times n plus 1 m1 square. Now it makes more sense. Now you see, you take this to other side. So it turns out summation of 1 to n xi square. Now this is beautiful. This turns out that it's greater than nxn plus n into n plus 1 times m square minus m1 square. Now this is making more sense, because you see automatically this m minus m1, this things comes up like this. So let's rewrite this whole thing, which I have done a mistake over here. So it turns out that s is a relationship with s1. Sorry, s has a certain relationship with s1 if and only if this relationship, if summation xi square 1 to n has the same relationship with n xn plus 1 plus n times n plus 1 to m square minus m1 square. Yeah. So this is a if and only if relationship. Like this happens if this happens, and if this happens, that happens, because the set of the set of equations are transferable. So now for the first case, if m equal to m1, this becomes 0. So it's asked that summation of this becomes 0, is nothing but this. Oh, I did a mistake. This one. So if m is equal to m1, we know that xn plus 1 is also is equal to m. So this. So now what is true here? It's simple. It's very simple because um, if you take this on the other hand side, you get this minus m squared. Now what is this? This is nothing but s, right? And standard deviation is always greater than equal to 0. And in this case, it shouldn't be equal, so it's greater than 0. That means s is always greater than s. Now the intuition, and that's why I was a bit concerned while a different few equations were coming. The intuition is very simple. The intuition is this, that if you have a set of numbers, it has a certain dispersion, right? Certain spread. If you add a number in between that set, the spread should decrease, right? That does that make sense intuitively, guys? All of you? There's a set of numbers. If you add this a certain number in that, automatically the spread will decrease, right? The dispersion decreases because you're adding the same a number in that same region. A spread will only increase if you add a far away number. What is standard deviation counting? It's measuring that how much each of the numbers is deviating from the mean. So sum of squares of that. So if this is the mean, it's seeing how much is the distance from each one of them. And then it's taking the square of that and summing and averaging it. Now, if you add a far away number, what happens is that, first of all, the mean shifts a bit, but the distance also shifts from all others. So essentially, you can intuitively understand that what the standard deviation is counting is nothing but how much data is spread out from the mean. Okay, that's what it means. Now, if since you're adding the same mean here, the mean remains same, but what is happening? The number of data is increasing, so this is increasing. So it's like the average, right? The average is decreasing because the data is reduced, the dispersion is reduced, kind of become more. So you can think of dispersion as the density of the, like, if it's more spread out, that its density is less, right? Now, if you add a single number again in that small space, the density increases, right? So that's the meaning of the intuition of the dispersion here. So it's, if you compare density to this, that means that's how it makes sense intuitively. So this is S1 is always less than S. That should always be true. S1 is equal to S if and only if. So let's see all the conditions. S1 is equal to S if and only if this is 0. That means S is equal to 0, which is never possible. That means all the numbers are same. So this is never possible in this case. So we will also check other numbers because that's a learning experience. If M1 is less than M, then what happens? If M1 is less than M, then what will happen? Can we do anything here? What if M1 is less than M?
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.